Okay guys, we are going to get started here on our section 3.6 notes, so that way you guys are able to get going on the homework for that. Sorry for the late post. I will do my best here to put this up for you. Okay. First thing we're going to talk about here is just going over again, looking at how to figure out certain values. This is just our warm-up, so if you guys want to pause and try this on your own first before we go ahead and do it, we can get going here, but otherwise we will start. So if you guys remember, vertical angles are congruent. Okay, so this means that these two are going to be equal. So we got 16x is equal to 9x plus 42. So we're going to solve here. So minus 9x on both sides. So we get 7x equals 42. Divide by 7. So x equals 6. Okay. So now that we know what x is, remember we're trying to solve for x and y. So we know that x is 6. So then we could now figure out what our y value is, because now that we know what x is, we get rid of that value. We do know that these two form to make a linear pair. So what we can do is put in that x value. So we've got 9 times 6 plus 42. Okay, so 9 times 6 is 54 plus 42. Okay, and we add those up, we should get 96. Okay, and then we can add that with 15 times 9, no, not 9, excuse me. Okay, 15 times 6 plus 6y. Okay, so 15 times 6 is going to be 90. So 90 plus 6y. Okay, so you know what that is, right? So we've got, now we've got plus 96, and that is going to equal 180. Okay, so 90 plus 96 is going to be 186 plus 6y is equal to 180. We subtract 186, so we get 6y is equal to negative 6. Divide by 6, so y equals negative 1. So there are your answers for that there. And again, we can have a negative value because we're not finding degrees, we're just finding the values of the variables, and they should make this true. Okay, so that's your warm-up for today. So we are going to start with our last section. This is the last section of Unit 2. So normally we would be taking a test after this, but we are not going to be doing that just because we can't with the meeting paper requirements. So what I'm going to have you guys do here is just take the notes. We'll go through, and then you guys can do that homework, and then we'll actually start with a little quiz tomorrow on basically what we've learned from 3.4 to 3.6, and then we'll start with the new unit the next day after that. Okay, so 3.6, prove theorems about perpendicular lines. Okay, we're going to come up with 4 theorems today, all right, in this section. So we're going to have those written down, and it's applying properties of parallel and perpendicular lines. Okay, so our first one here, it says if 2 lines intersect and form a linear pair, and the 2 angles are congruent, then, okay, so let's make sure we read this again. If 2 lines intersect and form a linear pair, if you guys remember, a linear pair has 2 lines that form to make a straight line, which would mean that their measures are 180 degrees. And if the 2 angles are congruent, then you can state that the lines are perpendicular. Okay, so if 2 lines intersect and form a linear pair and the 2 angles are congruent, then the lines are perpendicular. This is called, this doesn't have a name. Actually, there are 5 theorems. I lied. There are 4. Okay, so basically, if you know that these 2 lines intersect and form a linear pair and the 2 angles are congruent, they must be perpendicular. Okay, I know there's a lot of words to these, but if you can understand that they are pretty much just stating things you guys already know, this actually works out really well for you, okay? Next one. If 2 lines are perpendicular, Okay, so we've got two lines here that are intersecting, and we're saying that they're perpendicular. Then they intersect to form 4 right angles. Then they intersect to form 4 right angles. Okay, so if we have two lines that are perpendicular, that we know that are perpendicular, then all 4 of these must be perpendicular to each other and make right angles. Okay, so that means we would have 4 right angles, which would equal a sum of 360 degrees. Okay, so those are our 2 perpendicular theorems. Again, you should know kind of the logic of these based on what we've already talked about, but again, it's always good to go back and look at these and make sure you understand what it is that you're actually doing. Okay, if 2 sides of 2 adjacent acute angles, okay, 2 sides of 2 adjacent acute angles are perpendicular, then the angles are, anyone guess it? Complementary. Okay, so what this is saying is if we have 2 sides of 2 adjacent acute angles are perpendicular, meaning that these sides are perpendicular, that means that the sum of these angles has to be complementary. So I really should be putting a right angle symbol in the middle, because remember, complementary angles mean that they have a sum of 90 degrees. Okay, so if these 2 side angles here that are in red, okay, are perpendicular to each other, that would mean that those 2 angles have a sum of 90 degrees. Okay, hopefully that makes sense. Again, if you need to pause the video to watch these again and go over like what to write down, feel free. But just understand that these are going to be used a little bit when you do your homework. Okay, now we're going to move on to these 2 actually have names. Okay, so we'll go over what they are and go through over the then, and then what I'll do is I'll write the name above the words here. So it says, if a transversal is perpendicular to one of the 2 parallel lines. Okay, so what we would say here, guys, is that H and K are perpendicular. All right, and if one of them is perpendicular, okay, so that's what it's basically saying here in our if. Okay, the then would that then state that if this is true, then it is perpendicular to the other line. Okay, what this is basically saying is, so if a transversal is perpendicular to one of the 2 parallel lines, then it is perpendicular to the other. Then it is perpendicular to the other. So guys, basically what that's saying is using our corresponding angles theorem here, knowing that if we have 2 parallel lines in H and K, and that first intersection is perpendicular, then the second one must also be perpendicular. So this one is called the perpendicular transversal theorem. Okay, so this one is called the perpendicular transversal theorem. So if a transversal is perpendicular to one of the 2 parallel lines, then it is perpendicular to the other. All right, so that is a theorem that we do not need to have any further proof. It's just going to be, it's one of those things that's always true. Okay, and then another example, it's kind of a reverse of this. It's saying in the same plane, if 2 lines are perpendicular to the same line, so this is saying that line M is perpendicular to P and line N is perpendicular to P, then they are parallel to each other. Okay, then they are parallel, not parallel, parallel to each other. So that's basically saying that M is now going to be parallel to n using that fact, okay? So this one is called the lines perpendicular. Lines perpendicular to a transversal theorem. Okay? So again, these theorem names are a little long, but you should be able to figure out and understand the point and the purpose here. Lines perpendicular to transversal theorem. If in the same plane, two lines are perpendicular to the same line, then they are parallel to each other. Okay? So that's your last theorem that you're getting from today, and then the rest is just going to be application of those theorems. All right? This one's more of like you got to understand your knowledge, your concepts in order to answer the questions. Okay? So we've got a diagram here with lines RST and lines MN. Okay, now I know that a lot of them appear to be what they are, or like whether perpendicular, parallel, etc. But you have to make sure you understand that you need to have physical proof using those theorems in order to answer these questions correctly. So if we start with number 16, it says, is R parallel to S? So we're trying to decide if these two lines are parallel. So we are going to be using those last two theorems we just went over. So the perpendicular transversal theorem or the lines perpendicular to a transversal theorem. Now, there's nothing on this diagram that indicates anything is parallel because that's what we're trying to prove. So we don't know that R is parallel to S. So what we need to look and see is, do we have either a transversal that is perpendicular to one of the two parallel lines, or in a plane, if two lines are perpendicular to the same line, then they are parallel to each other, okay? So we can't actually use perpendicular transversal theorem because we don't know that R and S are actually parallel, okay? And we don't know right now that M and N are parallel. But what we can say is we actually don't know if there are any right angles with R being a transversal to M or N. S, we do know there are some perpendicular lines, but we do not know anything about R. So in this example, number 16 is actually going to be no. Okay? Since R doesn't have any perpendicular angles indicated, we cannot in any way, shape, or form, and because we don't know that any of the lines are parallel right now, we cannot indicate that this actually is a parallel set of lines. So in this example, 16 is not parallel. Okay, we do not have any indicated angles that would imply that they are actually parallel here. So if we move now to 17, so is M parallel to N? Okay, so we're looking here for M. Now, we have M and N. I'm going to erase here. Here we're trying to see, are these two parallel? Okay, we have a little bit more to work with on this one. All right, so if we notice, we are trying to prove things are parallel, so we're not going to be using the perpendicular transversal theorem. We're actually going to be using lines perpendicular to a transversal theorem. So, do we have two lines that are perpendicular to the same line? And in this case, yes, we do. Okay, we have this angle here with S, and we have this angle here with S as well. So M and N both have perpendicular angles. So in this example, we would say 17 is yes. And we could say, using the lines perpendicular to transversal, okay? So that's basically saying and stating our example here and indicating with the angles circled in red, okay? Now, we'll move on to 18. Is S parallel to T? Okay, again, we're trying to see, do we have a set of perpendicular angles that would allow us to prove that they are in fact parallel? And again, we have two sets of perpendicular angles here that allow us to say, yes, there is a transversal that forces us to come to the conclusion that S and T are in fact parallel. So S is parallel to T. Because again, lines perpendicular to a transversal. And that transversal is N in this example. Okay? Again, hopefully this makes sense. Again, it's just using your knowledge, guys, of the theorems and understanding what corresponding angles and those equivalent angle relationships from before tell us, okay? Okay, now here we got a diagram of a bunch of lines intersecting at a single point, okay? So we're going to find the measure of each of the missing angles. Right now we have 1, 2, 3, 4, 5, and 6, okay? So to find the measure of angle 1, we're actually going to have to do something in the first place here. So there's a couple of diagrams here, a couple of actually notation things here that help us. So we do know off the bat here that angle 6 is going to be congruent to angle 5, okay, because it has those two indicated marks, okay? We also know that the sum of angle 3, okay, the sum of angle 3 in this here has to equal what? So we're actually going to be able to answer angle 3 very quickly here. So we know that angle 3 is going to equal 90 minus 65, okay? So if we subtract that, we should get 25 degrees. So we know that angle 3 is 25 degrees, okay? Now what we can do is, according to our intersection here, I would say that this line has indicated enough that it is a straight line all the way through, so we could then say that angle 1 is also, whoopsies, it's also 25 degrees because those are vertical angles. Angle 1 is congruent to angle 3 because of those vertical angles, okay? Now, next one, we could try angle 2 here, okay? Since we have perpendicular angle between right here, so that would also imply that this has to be a perpendicular angle, okay? So then we could say that this is now equal to 90 minus 38, okay? 38 degrees, and if we were to subtract that, we should be able to get our answer here of 52, oops, let's back that up, equal to 52 degrees. So angle 2 is equal to 52 degrees. Okay, I'm going to put boxes around these so you guys can see what those answers are if you can't find them. Okay, all right, how about angle 4? Now, angle 4 is not a vertical angle, because if you can tell that we actually have completely different sized angles. So we cannot say that they are congruent here, because they're not vertical. So we're actually not going to be able to use those vertical angle theorems. So what we could do instead is what? What are some options here? Okay, we do know that the sum of our angles on the right side are 4 and 5 have to be what? They have to be 90. We don't know what angle 5 is. Okay, angle 5 and angle 6 have to be the same. What else do we know? Okay, we could find angle 6, right? Because we know angle 1 is 25 degrees. Okay, we know angle 1 is 25 degrees, so what would that have to make angle 6? Okay, is that going to be a vertical angle to 65? Well, yes, it is. So this is actually going to be 65 degrees as well. So angle 6 is 65, which would imply that angle 5 is also 65 degrees because we said that those are congruent here. So then our last remaining angle, so we'd have to do 90 minus 65, which we've already done, which equals what? That does equal 25 degrees. So if we have all these here, okay, that should give us our angle measures. The only one that's kind of goofy there is that little bisector, or not bisector, but this little line here, that kind of throws everything off. Otherwise, we had vertical angles going almost all the way through, okay? So again, just using our angle relationships to figure that out. Hopefully, you were able to follow all of that. If not, go back, watch the video, and again, please feel free. I do have a whiteboard, a giant whiteboard at my house, so if you guys need me to send you quick little videos to help explain some of the stuff, feel free to do so, okay? Our last one here, we're actually going to skip this, okay? So we're going to skip this example. The last one, if you guys want to pause to try to figure it out, what this one is first on your own, but this is basically using what we know. Okay, so we have two sets of parallel lines. We've got, looks like 4 angles here to work with. Okay, so we are going to use our knowledge here of what we just did using those theorems, as well as being able to understand how to do some of the other examples as well. Okay. So we have one angle that's 30 degrees, one angle that's 45, one that equals 2x plus 5, and the other 3x plus 5y. So we need to find the value of x and y. So this is similar to that warm-up problem that we did at the beginning of the video. So we're going to use what we know about angles to solve this, okay? So we have parallel lines and a couple of transversals, okay? So how could we start? So looking at this here, we can't really deal with that angle that has a y in it right now. So we got to figure out what we can do to figure out what the x is first. And actually, as you notice here, you can see that this angle is going to be congruent to this one here, because corresponding angles are congruent if you have parallel lines. So we know that 30 is equal to 2x plus 5. So I'm going to solve for x. So I get 25 is equal to 2x. Okay, divide by 2. And I'm going to get x is equal to 12.5. Okay? So using that now, we are going to be able to figure out what our y value is. Okay? So given we have our x, so if we did, I'm going to erase this here, so if you need to get that on your own, please feel free to go back. What we're going to say, 3 times 12.5 plus 5y now. So if we multiply that, we should get 37.5 plus 5y. Okay, so that's our new expression for that angle. Okay. We also have that angle of 45 degrees. So we actually have angles here, if you guys can see. We have these ones here. Since we have parallel line cut by a transversal, we know the sum of those has to equal 180 degrees. So what we can do is we can substitute that in. We know that this one is equal to 30. So we're just going to say that it's 30 degrees. We don't have to plug in x in because we know what that is. So we're going to do 30 plus 45 plus 37.5 plus 5y is equal to 180. So we're going to add all those up. 30 plus 45 plus 37.5 is 112.5 plus 5y is equal to 180. So I'm going to subtract 112.5 from both sides. That cancels out. 180 minus 112.5 is going to give me 5y equals 67.5. Divide by 5. And I get y is equal to 13.5. So you should have got x equals 12.5 and y equals 13.5. Now this is just using our knowledge of perpendicular and parallel lines, not necessarily perpendicular lines, excuse me, just parallel lines and transversals. But hopefully this was a good way for you guys to refresh your memory a little bit. But that's pretty much all I have for you. You should be able to do the homework assignment now. And I will be posting you guys a quiz tomorrow. What I might do is I might just take the assessment that I was going to give on this standard anyway and just make it a Google form, and you just have to submit your answers and I can grade it manually afterwards. So hopefully you're able to get this. If you need any help with the homework, again, please reach out. I am more than willing to help you guys get that squared away. But hopefully this was able to give you some insight, and I hope you guys have a great rest of your day. All right, thanks guys.